Thursday. Let me get in the picture here. So welcome to a SQL Server user group here in San Diego. Welcome from Australia as well. We do have a few people that I know. I know Armando, and of course my husband's representing tonight. So we hope you enjoy his presentation on Fabric Pipeline, his master and all. So if you haven't had a chance to join us here in San Diego, come down from Australia, join us. We're awesome. We're a great group of people on the forefront with Microsoft here, trying to learn and grow with technology. If you have any questions or comments, please just ask away. Eric is not a robot. He is a human. So he'll take your questions as you have them. Yeah, so welcome, Eric. Thank you. And the floor is all yours.
Thank you. Just a second while I get set up again here. Okay, so this really small group, feel free to jump in, ask questions anytime. Happy to answer them. Okay, welcome to Fabric Pipelines. This is just one of the features for Fabric is a pipeline. They have like data flows, data warehouses. We're going to be looking at the lake house, but there's a lot more to it than just Fabric Pipelines. So, hello, my name is Eric Dykes. Here is my LinkedIn information if you want to connect with me. But as my wife just mentioned, I help host this users group, as well as help host the SQL Saturday in San Diego. I've worked in IT for over 30 years. My passion is just to make data more valuable for people. I just passed the Fabric implementing analytics solutions using Microsoft Fabric, DP600. So I just passed that exam recently, so I hope you get some useful information out of this. Okay, this is not a sales presentation. I'm not trying to talk you into using Fabric or sell you into using Fabric. This is just my experiences with Microsoft Fabric and how I used it. Here it is. There are multiple ways to do this. This is just the way that I chose to do it at this time. And if you've done this in the past, anyone done this in the past, please share your story. Or even in SynOps, if you want to share your SynOps story is great too. The ideal here is we all share, we can all learn, and we'll all be better off together for it. With that said, let's talk about the word pipeline. For me, pipeline is like this definition from Oxford, a long pipe typically underground for conveying oil, gas, etc. Okay, this is just kind of a funny thing on how we name things here in IT. Clearly, this person to me used to work as a plumber in a past job to be able to call it pipelines. But I thought that was humorous. Okay, so I'm sitting down with my boss, and she gives me the problem that we're trying to solve. The problem statement is they have this Jira data. They've been using Jira for a little bit, and they're collecting all the stuff, and they want to analyze it, a way to analyze it. They don't like the tools within Jira to analyze it, and they want to be able to get the data out of there so that they can put it into a Power BI report and start reporting on it. So she tasked me or us with being able to do that. Okay, so let's talk about how this has been done in the past and the way we do it now. This is the old architecture we used to use. We used to have a SQL database on-prem. We could connect to it, connect to the tables, get the data, put it in a report for them, and we were good. Now we live in this new architect world where we have a user that connects to a SaaS application, and we have no access to that data. We have no responsibility for that data, and we couldn't get to it if we wanted to, because it's someone else's. It's a SaaS application. So now back to the problem statement. My inside voice. There's a lot of inside voices here, but this is the freak out mode. Freak out. I don't want to do this. What if I fail? What if I get fired or demoted to the help desk? I will have to sell my Star Trek memorabilia just to pay my bills. So that's the freak out mode that when you first get a project, you get nervous about it. Okay, now the pessimist kind of sets in and you're like, okay, calm down. how do I get this data? Do they want the current state? Do they want history? How long will the solution last? What problems are we trying to fix by getting this data? So you start rationalizing what we're trying to accomplish. And then the more optimist side finally comes out and, okay, this is the perfect fit for Azure Fabric pipelines. Um, okay, this slide is a little bit salesy, but this is the purpose of what we're talking about. I've used this in the past with great results, and it is easy to use. I can do a little work, and everyone would think I spent weeks creating this solution. And I want to be the hero to accomplish this. So now this is that self-empowerment. We can do this. I can do this. Okay, so here's the analysis phase. You've got all this information. You've asked yourself the questions, and you start researching. Okay, Jira does support APIs, REST APIs, so I can get the data using Jira APIs. And of course, we want a low code solution, so just use pipelines. Don't try to use all Python notebooks or anything like that. And let's use a staging table. Like we'll get the data, put it in the staging table, and then from the staging table, we can update the production table that we have. So that sounds like a great solution. And let's use Upsert. Upsert's one of those new terms I've heard about in the last year or two, I guess. But we'll talk about that a little bit, the ability to insert and update data. And then let's take advantage of that Azure Lakehouse we keep hearing about. This is the kind of PySpark um, um, experience. Behind the scenes is PySpark. We can take advantage of that technology and be able to use the data from there. Okay, so here's the Fabric data pipeline that we're talking about. If we start off with this first box right here, can everybody see this okay? Is this big enough?
Yeah.
Yeah,
Okay, you guys are good. Okay. This initialized notes, Armando, this initialized notes is where we set up our first variable, and we also use it for documentation. You'll see that I thought that was a neat feature where you can start adding your documentation in here. Now this pagination, I want to call it pagination, but it's pagination, like pageant. Again, one of those play on words. Pagination is where we take that API, we do our first API, and we get like the total records that we're going to use in this pipeline that we're using, like 277. It's going to tell us that we're going to get 277 records. And we'll see an example of that. This get sequence number, again, this is our variable here that we just assigned. And that pagination, we need to convert it over to be a sequence number, like 1, 2, 3, 4. This is how many times the API will run to be able to get all the information. Like the API will only give us 100 records at a time, and we need 277 records. So we need to go run that API 3 different times to get all those records. And this is the first Jira pull, but the most important thing about this one is when we're saving the data to the staging table, this does the replace or the override, I meant. So the staging table needs to be blanked out before we use it. This is what gives us that functionality, as well as it gets the first 0 through 99 records. And this loop right here, this is what does that sequence number loop that we get. So it'll loop it once, twice, it does it once here, so it'll do it twice here to be able to loop through and get all those other 100 records from the API. Then this is the upsert where it does the update and insert. But again, unusual technology. We'll talk about it a little more. Okay, so pagination, let's drill into that one a little bit because there's a little map that we'll be using this for. So this is what the output looks like from the pipeline. We'll show examples of this, but pagination is normally you get something like start at, max records, total. So again, we're getting 277 records. We get a max at 100 at a time. So this means we need to do this 3 times to be able to get all those records. Okay, and then on the get sequence number, this is us doing the math to be able to take that 277. If we divide it by 100, we get 2.77. If we change that to an integer, we get 2. Now, what does that look like on our pipelines? It looks like this. This is our 277 right here. We're getting it from that previous pipeline activity. And then we're dividing by 100 right here. So that gives us our 2.77. And then this right here gives us our 2. It just truncates that decimal point and gives us the number two, whole number 2. Any questions so far? That makes sense? Good.
No.
Okay, moving on. Okay, now we're going to talk about that loop. So here is the variable, or no, the formula we put in for the loop. We use a math function called range. So range is like 1, 2, 3, 4. It's just range 1 through whatever was in that variable, which we said was 2. So loop 1 through 2, which just gives us 1 and then 2. Pretty basic for the way that works. And then now we're talking about this API pull that's inside the loop. This one's a little more tricky because it uses a relative URL. This is an example of that relative URL. But what we're doing is we're concatenating for the URL is like REST API version 3. There's a search feature for this API that we're using. And then this is this query that we have to put in to be able to do that. This query, what it does is limit the data that it's going to return to us for just the like 2 days or 3 days of data that have been updated, the data that's been updated in the last 3 days. So that's what this query will do for us. And then to start at, now we need to convert that 1 into a 100. So this is how we do that. This will give us the 1 number, and then we have this multiply 100 to the 1 number, and then we need to convert it all back to a string so we can concatenate it with the rest of this string that's already up here. So the stuff we're looking at is like, here it is, the 100, the 200. So this is how the relative URL will look. Now, I simplified this because really in when we go to the demo, you'll see these 2 things also inside this filter where we're saying order by updated. Give me the most updated ones first. And then we're saying max results equals 100. We know the max for this is 100. We want to make sure we get 100 at a time. So we specify that in our API. And then this last API, this is a Python notebook for the upsert. I looked at this for try to do it in the pipeline by itself. It did not have the functionalities. I looked for this in data flows. They have an increment type thing going on, but not an upsert like we have here. But an upsert is just, it looks for a key, where the key exists, like an ID that we all use in SQL. And we say, if it exists, update all the fields there. You can select the certain fields, but probably just update all the fields that are there. Or if it doesn't exist, insert the record into the table. Okay, well, we finally made it to the demo. That was all the slides. So let me stop sharing for a minute. Any questions so far?
Instead of using the Python, can we use just like the merge statement in SQL?
Can you use just a what statement? Oh, merge.
Yeah,
Oh,
the merge.
you'll see that. Yes, I mean when we flip over there, it will actually be the merge statement.
Okay.
There's not really an upsert. There is, you can do this through a SQL kind of. Well, we'll talk about it when we get there. I'll stop.
Yeah.
Give me just a second. Let me share my screen here. And then bring over oh, this is it. Okay, so this is our what was Power BI, which now includes Fabric. If I go to Power BI right here and hit, the only thing it gives me is new report, and you can see it already threw me into creating a report. But if I change this to data engineering, now I have all these other things I can, oh, let me get rid of this. All these other things I can grab right here. And the first one being the lake house that we are going to create. We're going to create one. We're not going to keep this one, but just an example of how easy it is. Ticketing data 2. And we're going to create this lake house. And here you can start to see tables. There's some files you can add, like CSV files you can upload to here. Oh, anything I get wrong, it's Armando's fault. He helped me. But if we go out of here, we look for that ticketing data 2, you can see how it created these 3 different entries. The first one is the lake house. You guys really click on it, you get to the tables, you can see the lake, what you would expect to see in a database. The next one is this semantic model. This is a default semantic model. My understanding of this is they give this to you so you can start using the data in the lakehouse from a semantic model. I don't think it's used very much, but it is still there to be used. The SQL endpoint, this is how you connect to the database from like a SSMS. You go over here, you can get your connection string, and this is the server name you would punch in to get access to it. Now, for our example, I'm going to delete this one, but this is the one we're going to use, and I'm going to copy the connection string here, bring over my SSMS, hit connect, database. I'm typing that server in there. This is the username I'm using. It's MFA, but I've logged into this recently, so it shouldn't prompt me for anything. You can see over here, we have a database called ticketing data. We have tables, views, program. We got stored procedures. So there's a lot of functionality in here we can use from this Spark kind of database. But we have no tables. I think in Synapse, you see things underneath external table if you've configured it that way. This one, it shows under tables. But okay, so proof that nothing's there right now. So let's get this out of the way and dig into our pipeline. And bring up my notes. Okay, this is that first one, initialized notes we talked about. Again, this is a great place to do documentation, created by date, anything you want to in here that would help the next person who comes in here see what is going on or knows what's going on. A link to other documentation that's in Confluence or something like that. This is a great place to put it. Okay, this is starting that sequence number. All I did was hit new, say sequence number here. I did change this to an integer and hit confirm. And then I just typed in 0 here. So that's that first step, pretty basic, nothing to it. This one right here, wait a minute. I gotta clean up my demo here. Go to my connections. These are the REST APIs, but I want to create these with you, not already have them created. So let me get rid of them real quick. Okay, so over here, we refresh, we see we have no APIs in here. So this is that pagination. We're looking to get that total number of pages. So we'll go more here. So start setting up the API. And we need to do a web page call for this one. You grab this some data here. Copy. There's the URL. Again, is that this is the Jira side of it, that base URL, REST, API 3, search, and then that Jira query filter. Let me go to the right a little bit before I'll try to zoom in like that. You can see right here, we're using the order by updated. So we get that newest records first type thing. And then down in here, we got the max results equals 100. That gives us 100 records at a time. So this is how we set up this API to get that data from Jira. Now we give it a useful name. I can do it without highlighting everything. So the name is just like it repeats the API, which sometimes is very confusing. So we'll give it a understandable name. Go to basic. Give it a username. Give it a password. The password is the API key. So I went on the Jira, went into security, said API, and they gave me a key for the API. So now I use that in place of my password for these API calls. Okay, so to test this, let's deactivate everything. Oops. Deactivate, and let's just run these two and see what we get. Save and run. So you see the inputs and the outputs here. These are the things we're going to be looking at as we run these to see what the results were. Okay, it succeeded. Demos are good so far, but let's see what it says. This is the exact screen we were looking at earlier. You're starting at 0, you get 100 records at a time, and we need a total records of 277. Again, if this was production and you were just doing 3 days worth, maybe you would get 50 or something like that. But for us, for this demo, 277. Okay, so pagination works great. We've checked that out. Let's move on to get sequence number. This is that one that requires a map we talked about. Now let me copy paste that in here and we can discuss it a little more. So setting up that sequence number, it's not going to be the number 0. That would be a fail. Paste this in here. What I want to do is show you how, let me cancel this, do that again. Show you how we do this. But okay, let's talk about this first. This is that same thing where this gets to 277 records. This divides it by 100. So you get that 2.77 number. And this just truncates off that decimal places, which gives us the number 2. So how do you do this other than just watching me copy paste it? Get pagination, which is our previous pipeline element. If you get that, it'll click that, it'll put the format in the window for you. And then we know we wanted that total that we saw in the output. So this will give us that 277 number. Now I need to divide this by 100. So I'll go here, go to math, go to divide, divide. Go to divide, and right there it is. Remove that one, say comma 100. Now this will divide that 277 by 100. Now we need to turn it into an integer. That's under conversions. And you go down to you see integer, and right there it is. Okay. This would give us that 2 number. Just like that. So these two should be equal now. And they are. So we'll get rid of this one and accept that one. Just wanted to show you. Now let's run it and see if we get what we're expecting. Sometimes as you're doing this, you have to start off with just the 277 records first. So check that out, look at the output, see if it says 277. Then start doing your math one by one, running it each time, seeing what that output says to see if you're getting the results that you're expecting. Okay, they all three ran, and we can see that sequence number now says 2. Just look at the input. No, it says 2. Yeah. This one just says get. This one just says sequence number. Sequence number. This is that output for the 277 that we see. And this one is that 2 number we were expecting. So this one is working correctly. It's changing that 277 to say with we need 3 total API polls total. The first one's outside the loop, and then we need the loop to do 2 of them for us. So let's activate the next one and see what we have here. And under source is that full, Jira API full is that same one. We wanted to pull the 0 through 99 records. So this is that first Jira API pull. That destination needs to make sure it is our lakehouse that's listed right here, ticketing data. And our tables, we shouldn't have any tables in here. We need to create these guys. Yeah, there's no tables, even though I can't get that to go away. So we'll hit new right here and we'll type in the table name. So this is the stage table that we're creating. We're wanting this data to be stored into the stage table. So this table is called stage. We'll create it. We'll look at our mapping here. And, if you, oops. You have to start that over. See, destination. Nope, still there. Okay. If you hit import schema here, it will read this API that you got here. Let's just go ahead and preview the data. So custom fields, you can see all the column names right here. Custom field 1017, ID, self, key. This is the same information you see in this mapping. ID, key, custom fields are down here. So this is like the data type, string, long. These are the items you're going to be saving into your data lake. Now, one thing I recommend here is don't save everything, only save the things you need. Rename these guys to be something more human readable, like just key, just self, just ID, whatever makes sense for what you're trying to do. But let's run this one time and see if everything is working for us still. Now, while this is running, one thing we're going to do here is cheat a little bit. This is creating our staging table, but we also need our production table. And with this pipeline, it makes it real easy. From a SSMS, we would go in there, we would say, take our staging table, create table, then rename the stuff to our production table and run the script again to create our production table. But with this, when it finishes, we'll use this same pipeline to create that production table with just a couple steps. Dum, 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 dum. Okay, it finished. Okay, let's see what these outputs say. Maybe. Okay, here's our 277 still there. Check. Still working. 2 still works. And this is what you want to look at here. Rows copied. I said I wanted 100 records. It said it copied 100 records into that table. These are some sizes things here. No idea. Files written 100, but rows copied 100. That's what we care about the most. You can look through there. Okay, that one's working. Now let's go ahead and create that production table like we talked about. And we just say new table again. Changes to no stage. Here's our production table. Create, run, save and run. Now, while this is running, we'll grab our SSMS, which we had no tables before. Let's see if it shows us anything yet. I notice there's a delay between what this shows and what this will show. Nope, no tables yet. There is a delay there. We'll come back to that. I lost it. Trying to enlarge it for you. Okay, this succeeded. So let's look at the output again. Again, we copied 100 rows to that production table. That's perfect. That's exactly what we were wanting. Now, the other thing we want to make sure that this says overwrite, like we're overwriting it on this one, and then we're appending it on this one. So this one, we're always overwrite that staging table so there's a fresh copy out there. But for now, we need to change this. Oh, hit refresh, get my list of my tables again, and click on that staging table. Now let's enable this for loop and look at the syntax for that one. Okay, this is the one where we want to do that loop. 1, 2, we want it to run twice. So let me get the notes for that. Here, good. We want it to be sequential. We don't want to do a batch count. And we don't want it to be 0. We want it to look like this. Now, how did I get this? Again, you go to functions, you go to math, we want to do this range function because we want 1 through whatever this number is, which we know is 2. This number right here is 2. So we want to start off with 1, we put a comma, and then we go to our variables. There's our sequence number, we just put it in there, and that is how we came up with the syntax for this guy. We'll delete all that, keep this, hit OK. Now, before we can run this, though, we got to fix this one down here. This is the one that has that relative URL, which is still in there. Okay, relative URL. But first, we got to fix this API. There's no API here for this. So I'm going to go to More. I'm going to put in this little base URL. Well, no, okay. This is the REST API that we'll be using. So put that in there. Put in this is the base URL. This is just that front part of it without all of the stuff we are going to append to it. We give this connection a human readable name that we like. So it's just base URL. Then we go to basic. There, put in the username and this API key. API key. Okay. Then we hit connect. We cancel. Okay, now we have that base URL in there. Now we have to worry about the relative URL. This is the one that's going to change and give us the 100, 200. It'll just increment itself as it goes through that loop. So let's do the dynamic content here. Look at that guy. And now let's look how we created this. This is mostly the same thing as that for URL we looked at earlier. If we go to functions, we go down to string functions. Yep, there's our concatenate. And we just hickey mark, paste in that part of the URL, that extra part, but to start at, this is where we want to increment 100, 200. So, okay, we know we need to use this for each that has that number in there. It's just called item. Oops. It's just called item. And now we know that it's going to give us a one number, but we want it to be 100. So we need to do this multiply thing up here. So we go to functions, math, multiply. I didn't put that in the right place. Okay. Math, we go to multiply right here. Then we say, okay, we want to multiply by 100, comma, and whatever that number is. So this will give us, if this was 1, it would give us 100. But when you try to run this, it will give you an error message saying, this is an integer. You need a string. So, of course, go back here, do your conversions, make this into a string, and it looks like something like this. So now this should match what's up here. You're taking that one number, two number times 100, and then converting it to a string so it will be concatenated onto this string. So let's just cancel out of that. Let me recopy this again in case I messed it up. But that's kind of how that would work. Then you can hit preview data here. Hey, this is an integer. We'll start at the number 100 this time. Hit OK. Let's see if we get any data. We get 277, but we didn't get any other data. It's just kind of like the pagination report. That one's interesting. Let me see here. Not a demo unless you can troubleshoot. Base URL, fine. Relative URL, good. Da 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 da. Everything looks fine there. Okay, we're going to go on and see. We'll come back to this. Let's run it. Let's see what happens when we run it. Okay, pagination. Pagination's running. 277. Check. Sequence number 2. Check. That's what we're expecting. That one's still running. This one, 100 records, check. One thing we didn't do here was look at the destination table. But it's already storing it in stage. It has the mappings already there. Let's see what it says. The first one already ran. Yep, it only ran one row, so it is definitely not working correctly. Troubleshooting is required. Yay. Okay, base URL. Oh, connection failed. Okay. That looks right. We'll troubleshoot this for a minute, and then if it doesn't work, we'll move on. That looks right. Okay. Jira pipeline. Let me just change this to full and see what happens. Yep, full works fine. So for the sake of testing, I'll get rid of that first. And we can zoom up here, zoom up here, zoom down here. Okay, let's just go delete that connection and start it over. Then we go to the pipeline. This is where we need to use that base URL pipeline. We refresh. It's not there anymore. We go to more. Say REST. There's nothing that says well, right? Nope. REST APIs. Plug in our base URL again. Plug in a simple name. Oops. We're at a basic connection. Email. Password. Connect. Okay, there's our base URL. We'll hit test connection. Should be fine. We'll go to our dynamic content. Paste this guy again. Same thing we had before. Hit OK and preview data. I was supposed to have to start at 0. Oh, there it is. Okay, 277 records. Let's try this one more time, but let's type in 100 again. Then we can move on from this. Oh, yeah, the 100 is what was doing it for us. Okay, let's move on. So now we're going to put a notebook. This is where we're going to do that upsert or merge, as you called it. That we'll create us a notebook right here. We'll give it a nice legible name over here. And we'll go to settings and we'll say new notebook right here. And we'll give it that same nice legible name. And then right here is where we would add in our code. It'll be very familiar. This is what we're calling the upsert, which is just a merge. In SQL terms, it's a merge. You can do this in Python using data frames. I've done this in Synapse using it that way, but to be able to use SQL, I think is a nice touch. But it does not know what these tables are yet, the stage table or the production table that we're using right here. So we have to add it. So we'll go to data sources, lakehouse, existing lakehouse without schema. And we have this target ticketing data and we hit add. We do that. Our tables should come up here. So I like this. When it first comes up, it says unidentified. But as soon as you refresh it one time, then you get the names of the tables you were expecting. And we'll just make sure these table names are the same thing that's here. And they are. Okay. Notice there's no save here. There's only a save as. Like this thing saves it as soon as you do it. So it's interesting. You got to just exit out of it to get out of it. And then when you get to here, the notebook is still not listed, even though you just created it from here. So we'll hit refresh and select that notebook right there. And this is what it takes in order to do that Jira pull. If we run this and that API was running correctly, all of this would work as it's supposed to. But okay, let's run it and see what happens. Any questions so far? Any comments? Anything you're doing like this in Synapse already?
Yeah, I tried to implement the similar logic by using data flows. Power BI.
Data flows, yeah.
It was a bit tricky to do the same thing. Yeah, but eventually we haven't done that like insert, like upsert stuff. We're just doing insert
Yeah.
to keep
the copy data here, this copy data one right here, this is what you would use instead of data flows. If it's just something simple, like for the data flows, it's like a true ETL where you're transforming the data as you're getting it. Is that the way you are using your data flows or trying to use your data flows?
Yeah, I mean, the goal was like to connect the Power BI REST APIs and to get the information about the tenant information, like all the workspaces, like report names, users, and what kind of actions are doing by the users to see like what are the most using reports or dashboards or what are the least
Yeah.
their reports. So for that, we were trying to use the Power BI data flows to connect the
Okay.
Power BI APIs, and it has the same limitation. Like it can retrieve at one shot, it can retrieve only 200 records. I guess that's what I remember. So
Yeah.
as we need to loop it again, like okay, after
Yeah.
200, go to the next, and try to pull all the data.
Yeah. Now, when I originally set this up, I did a while loop, like while records were greater than or less than 100, because I knew it would give me 100 at a time. And then if it ever dropped below 100, I knew that was the last one and it could exit the loop. But I found this for each loop much more easier to use that
Yeah,
way.
yeah.
But
Yes,
you can kind of see here. Oh, go ahead.
sorry, I did the similar kind of use case in exercise. Like it's easy
Yeah.
to do that. Similarly, like what you're doing there.
Yeah. Perfect. Exactly. So if we look at the inputs for here, we can see this one says this is our relative URL. It gives us 100. Oh, by the way, this is so much easier to work on than Synapse. For Synapse, when you start up a notebook, you got to do that wait 5 minutes thing while it
Yeah,
creates your instance. This thing is 11 seconds. Well, let's do it like this. Um, let me finish demoing first. So that was our 100. This one is our 200. And if it works correctly, now see, that should be 100 records each time. And then then this right here takes the staging table and copies it into prod. So let's go to our notebook here. Let me demo this. Like if I hit run all right here in Synapse world, you'd have to wait 5 seconds while it spun up your cluster. But this one will take, let's see what it says. 9 seconds, and it's already starting to run and update that. So much easier to work in Fabric than it is Synapse because of features like this. and being able to connect to that lake house right here to get to those tables, that makes it a lot easier too. Okay, 277 records are affected. It does have all the records in there. So now if we go to here, we say, oh yeah, like this does some automated show me the records kind of stuff in the Spark you can use. We'll let this finish, but yeah, see there's all our records right there now that we have in that Jira application. But now if you go to data, you go to our lake house, which is right here, tables, refresh. And then I just refresh our SMS console. You see the data right here, our columns. We'll do our select in our SQL. Again, from here, you would add this to a semantic model, and then from there, you bring it into Power BI. Now, one thing to note here, kind of what I hear people are doing on workspaces. There's a data workspace and a reports workspace. So you want all your semantic models into one workspace that users can access. And then people can create their reports in a generic folder, in their finance folder, wherever their report should be at, they can go in there. But you kind of want to centralize your data, if you can, into one workspace. And maybe like this one, use the premium features. Maybe you have some features in there you're using, but then you only have to use it on that one workspace and not for individual workspaces scattered everywhere. But if we go to data, yeah, here, like how we saw that. Go to SQL Analytics endpoint, you can click on that and get this different view of your data. Kind of what you're used to, SQL queries, select 100. SMS data, you can start using it through here. So this is how you would use the pipeline to get REST APIs. Oops. I will stop sharing for now. Any other questions? Anything I can help anybody with? Or Mondo can help anybody with?
Yeah, all good. All good then. I have a question regarding this REST APIs. So is it like, for example, the Jira REST API which you're using, it has limitation of 100 rows per a call. So is that like limitations for each different API? Like for example, Power BI REST APIs has limitation around like 200 records that can call at one time.
Right.
So yeah, so it has, that's what I'm guessing, like each REST API has got some limitations around the how many
Absolutely.
going to pull. Yeah.
Yeah. I think the ideal is if I had a Jira system database on my side, I wouldn't want somebody coming in downloading all their stuff all at once. It would tie up resources on my system. Where if you give them an API where they could only do it 100 records at a time, then you could spread out that load of people trying to do that, and it wouldn't put so much strain on your database server of whatever they're running on their back end.
Yeah. Cool.
Yeah, yeah, I understand why they're doing it. It is a pain in the butt to have to deal with it, but I understand why it exists.
Yeah. Yeah. Thanks.
Okay.
That's yeah. I don't
Yeah.
have any. It's a
Okay.
great to see how how
Yeah.
this incremental looping and fetching
Yeah.
the record very interesting in Fabric.
Yeah. Yeah. Absolutely.
Yeah.
Cool.
And
Okay.
there is one last comment I would like to say.
Oh, yeah, please.
Yesterday I read an article that there was a release about Fabric orchestration accelerator, which I read something in LinkedIn somewhere in the post. So I thought that would be a good use case for the orchestration instead of like I was trying to do some customized orchestration framework.
Mhm.
But later, like someone from Microsoft, they did that orchestration framework that is available directly on Fabric, so we can just use it. That's it. So it was an interesting one.
Yeah, if if you still have that link, put it in the chat for us. I haven't read it yet. It'd be a
Yeah,
good thing to share.
yeah, I will check that one moment.
Yeah, please. Mike, you still awake?
Yeah.
Okay. I appreciate you guys hanging out, listening to the speech. I hope you gained something from it.
Yeah, no, it's interesting to see what this fabric was all about. Like now, that was the first time I ever saw any of the screens, and it
Okay.
looks like a cool workflow tool. Like I wouldn't have
Yeah.
thought it was that, like that. I just was not fabric, and it's like this really complicated thing to put together. But now it looks like it's like a puzzle that you put together, and you just got to program it piece by piece, step by
Yeah.
step, like a big
Yeah.
step
Oh,
function. So,
it's a lot easier than doing the code behind it. That's for sure. Trying to do it through the Python code.
did this always exist, or like is this relatively new? Like, was there a previous product that this evolved from, or is this like a brand new offering?
Yeah, it's like he mentioned. Synapse is the parent for this one. So Fabric
Synapse.
mostly came from Synapse
Azure
as their
Synapse?
first iteration.
Okay, because all right, yeah, because I've heard of Azure Synapse, but like I didn't know it was like this related to this. I thought it was something else. Okay.
No, Azure Synapse Analytics, and then it was Fabric, and then you slowly saw all the features being added to Fabrics that was in Azure Synapse.
But it
Yeah.
wasn't like there wasn't like a precursor tool like on the SQL Server side. Like I've always seen stuff like SSIS and
Right. Yeah.
SSRS and
Right. On
whatever.
the on-prem side, SSIS was definitely the first ETL tool that they used.
Okay.
Yeah. Oh, yeah, definitely. Then Data Factory after that. And or I'm sure Armando has more history than I do, but then as far as I'm concerned, it was Synapse, although I'm sure it was something before it was Synapse. And then Fabric.
Okay. Interesting.
Yeah. Yeah, it's the progression. So it's interesting, getting better and better each time they progress it. But that's also an interesting thing because it's hard. Like some of these consultants. Oh, Armando, you came off mute. You got something for us?
Yeah, no, it's Fabric is like a integration of a lot of tools that were already there, and they were put together under the same SaaS offering umbrella. So on the data transformation side, you are talking about here, Databricks is not a Microsoft product, but works on the Spark engine, and
Mhm.
Spark is inside Fabric. So Spark is there, was there in Synapse, was there by itself. We had the data factory, which is more of an orchestrator than data transformation, because you do the data transformation outside the data factory, some other place. And yeah, it's hard to make a straight line, like parent, grandparent, grandparent. It's a collection of multiple other pieces.
Hmm.
What are those CDs called? Best of 1980s or something like that. They take the best of everything and put it together.
Yeah, the big hits.
Yeah.
Yeah, exactly. That's it. Okay. But let me share this slide. This is some more of Armando's wisdom here. As far as Fabric goes, KQL is for streaming, Lakehouse is Spark, and if you're doing the warehouse in Fabric, then you're talking about SQL. That's kind of the breakdown of the technologies that they use some inside of Fabric.
Yeah, these are 3 of 6 or 7 data engines there are there.
These are the data engines.
Mm-hmm.
Okay. Got it. Cool. Thank you.
I just pasted the Fabric accelerator.
Oh, yeah.
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 If you guys have time, we can just go through that.
Fabric Accelerator. Oh, nice. Armando, you got any history with this thing yet?
This seems to be a community contribution. This is not a Microsoft resource.
Right. Yeah. Yeah. Okay. So not widely used in the world yet. Sounds like.
This is the first time I've seen it, and as you
Okay.
can see, the repo doesn't
That
belong to
person.
Microsoft.
Right.
Yeah.
Yeah. Yeah. Got it. Cool.
I'm gonna check it out.
Yep.
Thanks, everyone.
Yeah. Thanks everybody for showing up. We'll see you in a month from now.
Have a nice evening.
Okay.
Thanks
You
for the
too.
presentation.
Goodbye,
Thank you.
everybody.
Goodbye.